Please welcome Jacob de Sutter, who will create a tiny house in under 1 hour. Jacob?
Thank you, Sander. Hello everyone, and welcome to this breakout session about BricsCAD BIM. The purpose of this session is it's not a feature demo, it's not to show you the new features of V20, it's more a kind of end-to-end workflow demo where we start from conceptual design and some volumetric studies, and we advance in the design to go to documentation creation, creating schedules, things like that. It's not hard to follow. And I'll just start with creating some geometry. So I'll just start with a box. And because it's a tiny house, it has a small footprint, so I'll just start with, let's say, roughly 5 by 5 meter box, 3 meters high. And I had this idea of having a wooden box with a shell around it with a slanted roof. So I can easily achieve this using some generic direct modeling tools. So I'm basically splitting up this solid in an outer shell and an inner box. And now using the manipulator, I can easily model this the shape I want it to be. And so my idea was to have this shell kind of rotated as well. So you have something like this. And so this would be the wooden box with then a shell around it. So I can actually already, to have an idea of what it would look like with materials, I can already just apply some materials on there. So we have a very quick idea of what it would look like. So I had this idea of having the shell in what we call a weathered steel or Corten steel. There is some debate as to whether this is an eco-friendly material or not, but for the sake of this demo, let's assume it is. All right. So currently, this is now just a massive wooden box. It's not hollow or anything. So obviously, we wouldn't be able to live inside there. So I'm going to shell this to make it hollow. And now I want to split this hollow solid. So now it's just one solid. I want to split this into multiple parts so I can assign different materials to it. So I can assign a material to the outside, to the outer walls, or to the roof, for instance. So I can use a tool called bin split to split this into several entities. I'll just hide this shell for a second. So now it's split into separate entities. They're not walls yet, they're just 3D solids. So as you know, we can classify any type of object as any type of IFC classification. So we can do the classifications later. So currently they're just solids. I'm also going to slice these corners off because I want to, the building is going to be supported by a steel frame. And the steel frame will have the columns inside these corners. So I will have these corners also separated so they can be created as a kind of covering. All right. And now I can just start adding materials again. So I want these walls to have this composition. I already created these compositions beforehand to make it a bit quicker during the demo. But of course you can create your own compositions and materials. Okay. So now we already have a basic design in place, so a basic volume study. I'm going to add some windows as well. We can easily do it. In this case, I'm just going to use these boundaries and create simple 3-panel windows, just like this. These windows are also parametric, of course, so I can change its parameters so it fits the situation better. If I activate this section, for instance, I can see so yeah, it's just entering some parameters. In this case, I have them memorized, so you can also copy these properties over to other elements. So one of the tools I showed you yesterday was AutoMatch. You can also match properties of windows, parameters of windows to other windows as well. So you don't have to go through this process for every single window. But like this, we already have a nice little window here. I also had an idea of having a window over here, so maybe on the inside of the building it's easier to see. A long, narrow window along the top here. And again, I'm going to use the same technique of just creating a boundary. And again, using this window create tool to create this trapezoid window. Now, obviously, the window, we won't be able to see anything through this window because we have this shell in the way. So I'll just model this hole as well. And again, I'm going to change the parameters of this window. They're the same parameters basically as the other one. Voila. I'm also going to, so currently this wall has now been split up by this window completely. So I'm going to separate this from the wall and assign a new material to this top part here. And so just like this, we have already a basic design in place, including the windows. Let's take a look inside and see what we can do for the interior spacing here. So this part of the building is actually high enough to have sort of a mezzanine or a second floor. So again, I'll just use some direct modeling, in this case just a simple box tool to create this floor slab. And again, just using some basic 3D manipulations, I can change its shape so it better fits the situation here. So this is basically the floor slab, the mezzanine I want to have. Currently, again, it's just a solid. I can classify it if I want to, but it's not necessary yet. I'll just do it. And also, I want to create a bathroom because every building needs a bathroom, of course. I'm going to do that using the polysolid tool. So this is a tool to easily create walls, but actually they're not walls yet. They're still just simple solids, which then can later be classified manually or automatically by, for instance, Bomify. And also apply composition here. So again, just the same wood material. And if we want to be able to get on top of this mezzanine, of course, we would need a stair as well. So I can use the BIM stair tool for this. It snaps to this edge here. Already get a preview. But actually, because of the limited space here in this building, I'm going to use more kind of a ladder instead of a staircase. So just a very steep staircase in this case. Oops. And obviously we need a way to get into the bathroom as well, so I'll use a library object, a door, to get inside there. Oops. And again, this door is parametric, of course, so if I move my section a bit, and so I section through it. Now I can see, I can change these parameters so it fits better. Now I also need a front door, of course, and if I in this case insert a door here, let's say here, this looks kind of stupid in my opinion because we have this nice slanted top here and the roof doesn't follow the same edge. So in this case, actually, I want to have a door that has this slanted top as well. Unfortunately, we don't have any doors in our library that have this specific shape. So I'm going to have to create my own door in this case, which luckily isn't too hard. I'm going to start a new drawing from a template. In this case, it's the window metric template. It's an empty file, but it already has some predefined things like, for instance, layers. Such as, for instance, the BC subtract layer, which is a layer which will define the geometry that will be cut away from objects. So in case of a door or a window, if we place a window in a wall, obviously we need to cut a hole in the wall. That is the volume that is defined by this BC subtract layer. And I can already draw the basic outline of my door, like this. And I wanted to have a slanted top. So I can just rotate this face. I don't know the exact value. I'll just say 20 degrees, but I don't really care about it. I can always change it later. Now, you may be wondering why I draw this door lying face down. It seems a bit unintuitive, but it's actually quite logical. If I insert a door from the library, you will see it's also face down. That's because we use a thing called dynamic UCS. When we insert a door, once we hover over the correct face, it will flip the correct side up because we dynamically change our UCS according to the face where our cursor is placed. If I would place my cursor here, you'll see the door flip like this. So that's why I'm creating my door lying face down. And now I can just, again, use some direct modeling tools to create my door. All right, and just like this, I have a simple door. I will classify this object as a door, so that when we insert it, it's actually recognized as a door. And now I can add this object to my library. So I can click this Create Component button here, give it a name, choose a category, doors obviously. I want to go back to my tiny house. I should be able to find it in my library here. I can see it here. And I can just, again, drag and drop it into my drawing. So that's basically how long it takes to create a custom object. But now I can see, because I didn't really care about the angle of this top of the door, it doesn't really fit the current situation. I could go back in here and start rotating these faces manually using direct modeling, but actually I don't want to do that, because what if I change my design later, if the angle changes, Or what if I need a similar door with a different angle on a different project? That's why I'm going to parameterize this door. There's two ways of parameterizing or constraining. One way is to do it manually. I don't want to do this manually for the entire door. That's why I'm going to use a tool called AutoParameterize, which will do all of the constraining for me without over or under constraining the model. And now we see here an entire list of parameters appear. This was one of our V19 tools, but we've improved it for V20 as well. And now I should be able to see what happens if I animate this parameter, for instance. See, this already looks better, because automatically it created the constraint between these two faces so they stay parallel, things like that. So I can start renaming my, my parameters. This one is angle top, for instance. So now I'm just renaming them so I can more easily recognize these parameters later when I insert the door. I can very easily change the parameters. So I guess you get the idea. Once we have this, again, I can add this to my library, give it a name. I don't overwrite my previous door. I can if I want to, but I'll just create a new one. And now I should be able to find this door in my library. So I'll just reinsert it. And now I should be able to find these parameters in its properties. And here I have them, and I can now, in this case, change my top angle to, for instance, I think it's about 75 degrees, so it fits better. Change my height a bit, things like this. So that's how hard it is to create fully parametric objects for your library. Right, I have one small thing to clean up. Currently this floor slab doesn't have a covering. I would like this to be wood as well, so I'll just create a simple new solid as a covering object. Just like this. And now I'm going to take a look actually at my classifications, because I've been modeling and I've been using some classification types, but I didn't really think actively about my classifications during the modeling. I can use the structure browser for this. I can see here, in this case, I have 3 lines, which I will remove, and some building elements. So all of these things have already been classified. We have 3 windows, 7 walls, 1 staircase, 3 slabs, 2 doors, then 6 building elements. Building elements are basically the trash can of classifications. If you don't know what something is, just call it a building element and you're fine. But actually in this case I do know what they are. They're all coverings basically. So I'll just classify all of them. And just like this, we have assigned the correct classification types to all of the objects in the drawing already. And now I want to take a look at creating some drawings. We have a tool that does this automatically. It's called Bomify. It will classify objects automatically based on its geometric features. So you may think I don't need Bomify anymore because it's already classified, but actually Bomify does more than that. It also creates spatial locations and assigns objects to these locations, so buildings and stories. It creates sections or elevations and floor sections, things like that, rooms. It also created these two floor plans, or floor plan section planes. One for the ground floor. And now I can use these section planes to generate some drawings. So I want to have some elevations, want to have some floor plans, and also this section that I've been using to section through my building, I can also use it to generate a 2D section, of course. I could take one of those section planes and manually assign a destination file, but actually there's a way easier to do this since V20. We can do this using the project browser. So I will create a project, and now I'm presented this sheet set setup. So we can use this to already have an idea of where the drawings will go. This is maybe a bit of a big layout because it's a small building, so I'll just go to a smaller layout, an A2 layout. This already fits nicely on this current scale. I can also configure some other things like this margin, for instance. But I'll just use the defaults. I also didn't really have a title block or anything prepared. It's just going to be a blank page with some drawings on it. But I think that's fine for now. And now we see here there's already some sheets in place, but they're all out of date, so we didn't generate these sections yet. I can update a section like this, the two floor plans, and now we can see what it looks like. So this was made automatically just from this model. I can also update all of these sections automatically in the background without having to worry about manually updating them. So I just have to enable the background update. Let's take a look at our elevations. Doesn't look too bad. Again, I'll just move around some viewports so we get a bit of a cleaner drawing. And then obviously later we can dimension these objects, we can tag them. Everything you know of a CAD platform we can of course do. And now our vertical section. So I can just cleaning up a bit. Okay. Now actually, when I take a look at this section, I can see that currently my steel shell around my building is just almost 20 centimeters thick steel. This is not very realistic. So I'm going to shell this object as well in my drawing. And again, just use the shell command to shell this object. Voila. And now later we can use our sheet metal functionalities to unfold this into manufacturable drawings as well. So now I should be able to, if I save this drawing, should be able to see this in the sections as well. Actually in the elevations it's not really visible, but in the section, now you can see it's updated as well. So I mentioned before that the building would be supported by a steel structure. So it's just a steel frame. Maybe it's time to take a look at that now, so I can start creating a frame, but I'll start by creating a wireframe model, so just lines that show the shape of my steel frame, and then later I can assign profiles to them. So I'll use this line as a basis, and I want to have a steel frame with at the bottom, basically I want to divide this into 3 by 3 cells. We have a tool called Panelized for this, but first I have to temporarily make a region out of this object. Now I can panelize it into 3 by 3 cells. So now we have a grid. I'm going to explode this grid because I just want to have lines, not a grid. And now I want the same grid projected on my roof. So I'll just use the structure browser to quickly show or unhide the roof. And I can project this geometry onto this face here. Just like this. And I'll just connect these two grids here together. Just simple lines. They're just lines in 3D space. If I take a look at my frame now, it's already starting to look like a frame. But I also need something to support this mezzanine. So I also have this this mezzanine here. I want to be able to support this as well, so I'll add some more steel frame here on this level as well. Again, just drawing some lines in 3D space. Okay, I'll just finish this up. By adding some cross beams here as well. Okay. So now we have this wireframe model in place. I can turn this into a steel frame by applying some profiles to it. So we have this profiles panel on the right hand side here. I can filter between different types of profiles, in this case structural steel. I want to have a European standard. I'm going to use rectangle hollow shapes. For the sake of this demo, I'll just keep it simple and apply the same profile to all of the objects here. So it's just a matter of dragging and dropping the correct profile on here. And I'll do the same for this roof frame here. I temporarily have to change my UCS so they're oriented correctly. Voila. And as we can see, there are some interferences because we didn't really think about how these things would be connected, but that's something we can solve later. For now, I have to do a few quick fixes first. So I'm going to union these three beams basically into one beam, obviously, because I want to have a continuous object. Do the same here and here. I'll do the same here and here, just to have continuous beams so we have some structural integrity. I might need to slice 2 of these beams up as well, because currently they're intersecting. And now we can use structural connect to make sure these intersections like this So now we can see all of these interferences are now solved. This looks pretty clean to me. Most of these connections, so this structural connect tool is a very generic tool that will analyze the geometry and try to make a proper connection to it, but not all cases are going to be very realistic. I would suspect that this could be prefabricated, so these 3 objects could be prefabricated off-site and then assembled on-site using these columns and welding them together. So we want to have some welded connections for all these beams. Let's just make sure they're all classified as beams. So we can create this simple mitered connection like this using L-connect, or I can create a connection like this. I want to have a mitered, but actually I can go here again and miter these again manually, but a user that knows BricsCAD BIM will also know that there's a tool for this. It's called propagate. So we can very easily propagate this detail all around our building. In this case, it should find 12 possible locations where it can find these miters. So if I just use propagate on these 2 beams, we see it finds these locations, but actually in this case it only finds 8. It doesn't find these 4. So I would expect this also to be able to be mitered, just like on the other cases. But it's actually quite logical that it doesn't find them, because it's not the exact same situation. Because I projected this grid onto this roof, this square is no longer a square, it's become a diamond shape. So this angle between these 2 beams here is not actually 90 degrees, it's more like 87 degrees. So it doesn't find this location as a possible candidate location for propagate. So what I'm going to have to do is I'm going to have to parameterize this detail. So I can save a detail of propagate in a library. I can give it a name, mitered connection, for instance. Choose a category. I can give it tags as well. I'll just type in welded. Doesn't really matter. I can choose a nice thumbnail. And just like this, it's going to be saved in my library. So if I open my details panel, I should be able to find this detail here now. So if I would now drag this detail into my drawing, I should have the exact same situation as before. So it launches propagate and it finds these 8 possible locations. But still it doesn't find these locations because this detail is not parameterized yet. So I can open the detail and choose Parametrize. I'll just go in the top view here. Wait a second. And I can see now, just the same as with the door earlier, I can animate parameters to see what they do. And we see here when we animate this angle parameter, it doesn't really solve this really cleanly. These connections here at the corner aren't maintained. So I can still add some custom constraints myself. In this case, I'll just have to add a coincident constraint between 2 edges. Same here. And now if I animate my parameter, I should hopefully have a cleaner connection. So I'll just save this drawing now, and if I go back to my tiny house, and again, just insert this detail into my drawing, I should find 12 possible locations. So now it finds these as well, even though there's a 3-degree difference between this one and the previous one. So just like this, we already have our 3 parts of the frame in place. Now I'll just add the columns back, and we can take a look at, well, there's still some interferences here, so I can slice them up real quick. Voila. Now I'm going to clean it up. Now we have our structural steel frame that doesn't interfere with itself anymore. Looks like a nice frame. But maybe I'll just take a look at my sections. If they include the structural model, so yes, they do. I can now see some columns here in my plan. I can start tagging if I want to as well. For instance, I want to tag this steel beam here. So it retains the information, so it's linked to the 3D object, and in this case it knows it has this profile assigned to it. Okay, there's a few more things I can show you, but actually I'm going to wrap up now. I think the hour is almost over, and thanks for your attention. I hope you learned something from this session. I hope you now have kind of an idea of how easy it is to model and to start creating a BIM model in BricsCAD BIM. And if you want to go more in depth about the new feature, I encourage you to go to the session in the main hall after this. So after the break, I think it's at 4 p.m. And yeah, thanks for your attention.